You know, from giant construction cranes to the very car you drive, there's this powerful, invisible force at work all around us. It's called fluid power, and honestly, it's one of the most essential technologies you've probably never really thought about. So today, we're going to pull back the curtain and see how this amazing force actually moves our world. Okay, let's just jump right in with a question that seems, well, kind of impossible. Think about it. A light little tap from your foot can bring thousands of pounds of steel and glass to a dead stop. How in the world is that possible? I mean, it's not magic, but it sure feels like it, right? Well, the secret is fluid power. The whole technology really just boils down to one core idea: being able to control and multiply the pressure of a liquid or gas inside a sealed-off system. That's it. That's the secret sauce. So to really get a handle on fluid power, we have to start with the absolute foundation of it all: pressure. This is the key that unlocks everything else we're going to talk about. So what is pressure exactly? Well, put simply, it's just the force that a fluid, a liquid or a gas, pushes against the sides of its container. And it doesn't matter if that fluid is sitting still or zipping around. Pressure is always, always part of the game. Now, this slide shows something really, really important. It's the key difference between solids and fluids. Look at diagram A. If you push on a solid block, that force just travels in a straight line. Simple enough. But look at B. With a fluid that's trapped, that force doesn't just go in one direction. The pressure pushes out equally, everywhere, all at the same time. And this principle has a name: Pascal's law. It's how you can take a small, easy push on one side and turn it into a massive lifting force on the other. It's the magic behind a hydraulic car jack, and it's also the secret behind your car's brakes. That's force multiplication in action. Pretty cool, huh? Of course, none of this works without the fluid itself. But you can't just use any old liquid or gas. They need to have some very specific qualities to be the real unsung heroes of these powerful systems. So when fluids are on the move, they tend to behave in one of two ways. You've got laminar flow, which is smooth, orderly, and super efficient, kind of like water flowing gently out of a tap. Then you have turbulent flow, which is just chaos, all messy and swirly like a raging river. For most of these power systems, we're aiming for that smooth, laminar flow to get the most efficient work done. So what makes a good hydraulic fluid? Well, there are a few must-haves. First up is viscosity. That's just a fancy word for its thickness or how much it resists flowing. Think honey versus water. This is absolutely crucial for lubricating all the moving parts. Then you've got film strength, its ability to form a protective layer that doesn't get squeezed out when things get tight. For safety, you need a high flash point so it doesn't catch fire. And finally, it has to be crazy clean. Even the tiniest bits of dirt can jam up a powerful system and cause it to fail. Okay, so we've got the basic science down, and we've got our fluid. Let's actually build a simple system, step by step. Every system needs a heart, and for us, that's the pump. But here's a really important point that trips people up. The pump does not create pressure. No way. Pressure only builds when something gets in the fluid's way, like a heavy object it's trying to lift. The pump's only job is to get the fluid moving. It creates the flow. And like any VIP, that pump needs a bodyguard. That's where the filter comes in. Its job is so important. It pulls all the nasty stuff out of the fluid before it can wreck the pump or any of the other expensive parts. Trust me, a clean system is a happy system. So the whole journey is actually pretty simple. The fluid starts out in a tank, the reservoir. It gets pulled through a filter to get all cleaned up. Then the pump gets it moving. It travels through some hoses until it reaches an actuator. The actuator is the part that does the real work, like a cylinder that pushes or pulls, turning all that fluid flow into serious mechanical muscle. So, having all this power is great, but the real genius of fluid power is how we can control that flow with incredible, pinpoint precision. If the pump is the heart of the system, then you gotta think of the valves as the brains. These little devices are basically the traffic cops. They tell the fluid where to go, when to start, when to stop, and even how fast it can move. They're in complete control. And you've got a valve for pretty much any job you can think of. Pressure control valves are like safety release valves. They make sure the pressure doesn't get dangerously high. Directional valves are like the switches on a train track, sending the fluid down one path or another. And flow control valves? They're basically the gas pedal for the system, controlling how fast or slow the final action is. And let's look at a super common example you've probably seen. That quick disconnect coupling on an air hose for a power tool, that's a brilliant little specialized valve. It lets you pop tools on and off in seconds without all the air hissing out of the system. It's so simple, but so clever.
So far, we've just been saying fluids in general, but the choice between using a liquid or using a gas, well, that's one of the biggest decisions you can make when you're designing one of these systems.
And that brings us to the two main branches of the fluid power family tree. You have hydraulics, which use liquids like oil, and you have pneumatics, which use a gas, usually just plain old air. The huge fundamental difference between them boils down to just one word: compressibility. Liquids, you basically can't compress them. Gases, oh yeah, they're super compressible.
And this unique property of gases is everything. Because you can squeeze them, they act like a spring. They can soak up a shock and then bounce right back to where they were. That is something that liquids just can't do. So at the end of the day, you pick the right tool for the job. Because liquids are incompressible, hydraulics are perfect for anything that needs massive, precise force. We're talking giant excavators, car brakes, or the landing gear on an airplane. And because gases are springy, pneumatics are the go-to for fast, repetitive stuff, like a robot on an assembly line, or for things that need a bit of a cushion, like a nail gun. All right, let's do a quick recap. What are the big takeaways here? First, the magic behind it all is Pascal's law. Pressure in a sealed fluid pushes everywhere, letting us multiply force. Second, a basic system is just a simple loop: reservoir, pump, valves, and an actuator to do the work. And finally, the type of fluid is everything: hydraulics with liquids for brute strength, and pneumatics with gases for speed and cushion. So, from the brakes that keep you safe to the massive machines that build our world, fluid power is this invisible giant doing all the heavy lifting. Now that you know the secret, I guarantee you're going to start seeing it everywhere you look, which just leaves one question: what other impossible problems are we going to solve with it next?